What's up, Algebra 2? Today we talked about a new chapter, so let's kind of cover some ideas, domain and range. So let's jump into it. Number 7, we're trying to talk about the domain. This looks like it goes forever right from the origin, and so the origin's at 0. So this is x greater than or equal to 0. And for the range, this arrow suggests that it's going up forever while going right. It's also going down forever while going right. So that's why we're going to go ahead and say that that's all real numbers. Let's talk about this one. Number 9, domain and range. I look like I'm starting at 2 and going less than. It's going left forever and ever and ever. So I'm going to say x has to be less than or equal to 2. And it does not have a boundary. It just keeps on going forever left. The range is different. It's not going down forever. It's only going down as low as this -2. Even though there's an open circle here and that point doesn't really exist there, it still exists all up in here. So I'm still going to say there are points that have the value of -2, but all the other points go greater than that because of that arrow there on the left. Okay? Talked about function notation, being able to plug in certain values. So this is called W of n. So you're saying 4 times 4 minus 2. So replacing that n value with 4, that gives you 16 minus 2, 14. Let's try one like this. This is probably the most challenging one on the page, and then you can try numbers 2 and 4. -3 times t squared minus 2t. We're going to plug in -6 to both parts. If you remember order of operations, we have to do exponents first, and that value would be 36 as a positive. These could go ahead and multiply to make 12. I still need to multiply here. So -3 times 36, I believe that's -108. Let's add 12. -108 plus 12 is -96. So you try 2 and 4, just plug those values in, and this one should still be negative, so like -1 multiplied by whatever 10 squared is, minus 4 times 10. We talked about function notation combined with combined with function operations, and this one is a minus. So let's start with what it says g of n is. We are subtracting what f of n is. -n minus 2n, -3n, 2 minus 3. I am making sure I subtract that to get -1. So you try 6, give that a shot, make sure you just add those like terms together. Maybe we'll multiply this one together to see if that's something you understand. I know this is multiplication because of that dot between the two. That is not a decimal place, that is a multiplication sign. So I have g of x, which is x minus 2. I have f of x, which is x squared minus 1. And so we need to start multiplying these together to see what we get. X times x squared is x to the third. X times -1, -1x. -2 times x squared, -2x squared. -2 times -1, +2. Now, I don't see any like terms, but we talked about standard form today. Standard form is when you rearrange the terms where the greatest powers are in the front. So x to the third is okay, but I really want -2x squared to be next, minus x plus 2, and then that one is done. Okay? So I'll kind of get you started on this one just so that you know what to set up. G minus h. G has to come first because if you put h first, then you're technically doing a different problem. H minus g is not the same as g minus h because that's a commutable operation. So I'm going to put x minus 4 here. And honestly, it doesn't look like a lot of those go together, but when you write this, you need to make sure that those signs are being subtracted. This one needs to be distributed. 3x times -2x, -6x squared. 3x times 2, 6x. And that's all. We don't know what x is. We can't plug that in. So that problem's kind of done. So we talked about what makes something quadratic versus cubic versus quartic versus constant. So let's kind of talk about that for a moment. This first one's a quadratic because of the leading exponent on that variable is a 2. This one has a power of 1. So if you flip back to our notes today, if it's a power of 1, we call that linear, which basically means this goes down 6 every time you increase the r value by 1. And there's only one term. It's just one grouping versus 3 numbers in number 11, which we call a trinomial. This one's called a monomial. Okay? So pay close attention to two things. What is the largest power and how many terms are there? What is the largest power and how many terms are there? Largest power, how many terms there are. So give those a shot. We'll check your work tomorrow. Email me if you have any questions, and I'll see you tomorrow.